nerve impulse. It fires all the way, or it doesn't do it at all. Okay, so when you have an action potential going down a nerve, once it starts, it's the full deal. So it doesn't have a volume control. The same thing with muscle.
That doesn't mean that the whole muscle is over.
So a motor unit is one nerve bundle, one nerve fiber inside of a nerve. So it's like this. You have one nerve that goes to a muscle, but inside of that, you have a whole bunch of individual nerve fibers. Okay? So those nerve fibers, probably should have made the muscle red. One nerve bundle is going to have branches that's going to go to a bunch of different fibers of muscle that are spread out throughout the whole muscle. But you're going to have a whole bunch of these. And muscles that need finer control, like hand and finger muscles or eye muscles, there's going to be one nerve fiber that's only going to go to a few muscle fibers, like 5 or 10, something like that. Whereas if you have a stronger muscle, like a weight-bearing muscle, ones that do major contractions, they're going to have one fiber is going to go to even different sources, say maybe 100 or 2,000 muscle fibers. So when a muscle, the way that they start contracting is they'll go by size principle, meaning that the muscle fibers that go to a fewer number of muscles will start first, and it's spread out throughout the whole muscle. So if you notice, if you contract your muscle, the whole muscle contracts, but it can still contract more once more of those motor fibers, motor units kick in. Okay? So initially you have some of the motor units are kicking in and you're getting a little bit of contraction throughout the muscle. And that follows the all or none principle. Once the impulse comes down this nerve, every muscle that it goes to, and every muscle fiber that it goes to is going to contract. But then you can escalate that when you have more motor units. From the brain, you can trigger more of those motor units that go to a wider dispersed part of that muscle. Okay? And then, this is probably getting into it a little more than you might need to, but you can have different patterns when people are training for different types of exercise. You can have synchronous activation or asynchronous. So somebody that's a power lifter in the Olympics, they want a sudden, strong burst of muscle contraction, right? So they're going to fire everything all at the same time, so it's synchronous. Whereas if somebody is a long-distance runner or something like that, where they need a little bit of contraction over a long period of time, they're going to be more asynchronous, where some can contract and others may not. Okay? So when we were talking about in that video where they're saying that not everybody uses all their muscle fibers, it's because not all the motor units are firing all at the same time. Okay? You need to fire some, and then those will do a small, low-level contraction throughout the whole muscle. But if you need more demands, then more of the motor fibers are going to contract, and you can contract more of that muscle. So that's what they mean when they're saying that not everybody uses all their muscle fibers all the time, because you don't have enough of demand to kick all of them in. Okay? Does that clarify that a little more? So basically, when we covered before, we covered the axial skeleton. And we got into all the details of the different parts of the bone. But we didn't talk about the appendicular skeleton. And that's what we're going to be doing now. Okay? So we're going to start with the shoulder girdle, go into the upper arm, and go into the forearm. And so we've covered all the different basics of the minute details of the muscles and the bones. And now we're going to get into the more generic macroscopic types of details. All right, so then as we go through the bones, and we talk about origin insertion, there's going to be different names for all the little knobs and things where the muscles attached to. Right? So we're going to be talking about the shoulder. Now this stuff that I'm doing is not necessarily in the notes, but it'll make sense in a little bit. Okay? So we're going to be talking about the shoulder girdle. Most of the, like on the humerus, most of the points where the muscle is attached to that come across the shoulder are going to be at the proximal end of it. Okay? That's because of the, without getting into all the details, with muscle levers and things like that. You're going to get a better, stronger pull on it closer to the joint itself. Okay? Now, when we talk about origin and insertions, there's different terms that we're going to use. And one is a general class of things which are going to be indentations, like fossa. Okay? So a fossa is usually going to be something where it's going to be an origin of a muscle. Okay? If we're going to talk about the scapula, we have the subscapular fossa, the supraspinous fossa, the infraspinous fossa. And we'll get into those in a little bit. But basically, those are going to be indentations, like little valleys or like on the inside of a saucer shape type of thing. So those are going to be wide spaces where muscles are going to, lots of fibers are going to attach to, and those are going to be origins. Okay? Other things we'll talk about are going to be condyles. And those are usually going to be articulating surfaces with joints. So we'll talk about in the elbow here, you're going to have condyles. And then, what's the word epi mean? Like near or around. Okay, so epicondyle is going to be what? Near the condyle. Okay? So a lot of times an epicondyle is going to be something that's going to, muscles are going to attach to. And those are again going to be, a lot of times are going to be origins. And then you can have a supracondylar ridge, which is something that comes up onto here. Okay, we'll go through all these details later, but this is just some general concepts. And then also you have a process. Like we talked about in the spine, you have a spinous process. Okay? Those can be origins or insertions. And then we'll get into things that are like little bumps. Okay, but we're in anatomy, we can't just use terms like bumps, we have to use fancier types of things, right? So they're kind of graded on size, right? What do you think is going to be bigger, a tuberosity or a tubercle? Tuberosity. And then a trochanter, that's going to be even bigger. Okay? So we'll have the greater trochanter here, and if you have a greater, then you probably have a lesser, and then you have tubercles. We'll talk about up on here. The tuberosity is kind of in between. We'll talk later about the tibial tuberosity here. So do you think those are going to be more likely to be origins or insertions? Insertions. Insertions usually tend to be smaller, discrete areas where origins tend to be larger areas. A lot of times your insertions are going to be closer to the actual joint, whereas origins, like some of the muscles in the forearm, the deeper ones, they're going to originate off of a longer surface of a bone. Okay, that's when you're going to talk about lines or crests or ridges, things like that. And then a couple other things we'll talk about is that you have a different notch or a groove, an intertubercular groove. There's going to be lots of weird different names for different origins and insertions. But in a general sense, the insertions are going to be just distal to the actual joint that they're working on, whereas the origins are going to be obviously proximal, and they tend to come from a wider, a bigger space, a bigger surface, right? So you have a fossa, like what we're talking about on the scapula. So here's the spine of the scapula, and then here's the supraspinous fossa, here's the infraspinous fossa. Those are going to be, so the muscle's going to come off from a larger attachment, and then the tendon's going to be on a smaller spot of an insertion. So those are just some general concepts, because as we go through all these different things about muscles, that'll make hopefully a little bit more sense.